Today, it's all about finding intercepts, so let's get started. Finding x and y intercepts. How would you go about finding the x-intercept of the graph below? How would you find the y-intercept? Well, first of all, let's identify them on the graph as a reminder. Your x-intercept would be this point right here. This is your x-intercept. In other words, it's where your line or your graph crosses the x-axis. Our y-intercept would be where our graph crosses the y-axis. Specifically, let's label these points. This one here is going to be the point -1, 0, and this one here is going to be the point 0, 1. Notice for our x-intercept that our y-coordinate is 0. So I can go ahead and I can identify the x-intercept as the x value when y equals 0. And similarly, look here for the y-intercept, our x is actually 0. So for the y-intercept, let's informally define that as the y value when x is equal to 0. So let's actually solve this problem without the graph, using this information. So if I was going to find the x-intercept for y equals x plus 1, the x-intercept is when the y value is equal to 0. So I'd have 0 equals x plus 1, subtract 1, and I get x is equal to -1, which is exactly what I have here. X is -1 when y is 0. And also, for the y-intercept, we are going to have the same equation, but this time we're setting the x value to 0. So we get y equals 0 plus 1, or y is equal to 1. And that's certainly true if we look at this point right here. When our x is 0, our y is 1. It's a really important reminder, but the most important thing on this whole page is this, having that memorized. All right, so find the x and the y-intercepts of the polynomial below. Well, I'm just going to remind myself right now that my x-intercept is going to be when y is equal to 0, and my y-intercept is going to be when x is equal to 0. So I'm going to go ahead and start with the y-intercept first. That's going to be the easiest one, when x is 0. So plugging in here, I'll have 0 cubed minus 5 times 0 squared minus 0 plus 5. Well, that gives me 0 minus 0 minus 0 plus 5. That's going to give me 5. So in other words, we can think of this as y equals, our y is equal to 5 when I plugged in 0 for x. So my coordinate answer is going to be equal to 0, 5. So now the harder part is actually finding the x-intercept, and that's going to be when our y is equal to 0. Well, we can set this whole entire thing equal to 0 because this whole thing is y. Y is equal to all of this, which we set equal to 0. So in other words, to find the x-intercept, we're just going to solve this equation. And so I'm going to solve it by factoring, as you can see from the title of this video. We're going to solve it by grouping, and that's almost always the case if we have 4 terms. I'm going to pull out an x squared. That's going to leave me with x minus 5. I'm going to have an x minus 5 here, and I do that because I immediately copy down the exact same thing, and then I determine that this has to be a minus 1, because -1 times x gives me this, -1 times minus 5 gives me that. All right, let's continue with this. This is going to become an x squared minus 1, and then I'm going to have an x minus 5. However, I can continue to factor because this is a difference of squares. So I can rewrite this as an x minus 1 times an x plus 1 times an x minus 5 equal to 0. So our answers here are going to be x equals 1 from this one, x equals negative 1 from this one, and x equals 5. And I'm totally fine with you leaving your answers as this, but you could also say that your answer is 1, 0, negative 1, 0, and 5, 0. So here are your x-intercepts and here are your y-intercepts. And let's go ahead and let's check that. Our answer makes total sense. You can see here that our y-intercept is at 5, and we have 3 x-intercepts here, here, and here. So our answer is correct. Let's go ahead and let's take a look at this one. So first thing I like to do is find my y-intercept, and the reason is it is much easier. So as a reminder for the y-intercept, that is when your x is equal to 0. So plugging that in, I get 0 to the 5th minus 5 times 0 cubed plus 4 times 0. That gives me 0 minus 0 plus 0 is 0. So my coordinate for the y-intercept is 0, 0. All right, now for my x-intercept, I set my y value equal to 0. And my y is this entire function because y is equal to blah, 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 blah. Set that equal to 0. And now I factor. So I'm going to pull out an x, and I'll have x to the 4th minus 5x squared plus 4. And you're going to treat this problem just like you would any factoring problem where I write an a and an m. Except this time I'm going to have an x squared and an x squared like that. So what adds to minus 5 but multiplies to 4? Well, that would be a minus 4 and a minus 1. Whoa, well, looking at that, I also see that I have 2 difference of squares. So I can go ahead and write this as an x minus 2 times an x plus 2. And then this here is an x minus 1 times an x plus 1. So I just made this into these 2 and this into these 2. So finding my x-intercepts, I get an x equals 0, x equals 2, x equals minus 2, x equals 1, x equals negative 1. And I don't really feel like rewriting those, but there you go. Those are my x-intercepts. And you could write each of these as coordinates 0, 0, 2, 0, negative 2, 0, and 1, 0, and negative 1, 0. Let's go ahead and let's check our answer. Well, gosh darn it, looks like we're going through all those answers that we had. It also looks like our y-intercept is correct because it goes to the origin 0, 0. I am elated. We are so smart. All right, let's do one more of these and then let's talk about something else. So here I'm going to pull out an x. I get an x squared minus 6x plus 9. I'm going to write am. What adds to minus 6 but multiplies to 9? That would be a minus 3 and a minus 3. And if I want, I could actually rewrite this as x minus 3 quantity squared equals 0. So here I get an x equals 0, and also here I get an x equals 3. And so these would be my x-intercepts, 0, 0, and 3, 0. So these are my x-intercepts. And my y-intercepts are going to be when my x is 0. So plugging in 0, 0, and 0, that all becomes 0. Let's go ahead and check this. Looks like we are correct. We've got our y-intercept at 0. We are going through x equals 0 or 0, 0, and we also go through 3, 0. Now, something important, something different that's happened here is the fact that we're actually bouncing off. And I've mentioned this before when we were dealing with domain, but if I have a squared here, that ends up being a bounce, right, as opposed to a crossing through. So we have talked about that before. Now, anytime you have what we call an odd multiplicity, what do I mean by that? Well, this is x to the first power. That's a multiplicity of 1. It's going to cross the graph. And anytime there's an even multiplicity, like it's a squared, it's going to bounce off the x-axis. So kind of going back to previous problems here, as a reminder for this problem, we got x plus 2 times x minus 2 times an x on the outside, x minus 1, x plus 1. All of these binomials and this monomial have a multiplicity of 1. See how these are all to the first power? Meaning that it does completely cross through at those points. All right, let's discuss that more. So this graph here says if you have a root, which is the same thing as having a solution or a 0 that has an odd multiplicity, meaning you have something like, I don't know, x minus 3 cubed, or it's just plain old x minus 2 to the first, although that 1 won't be written there, it would cross the graph. If you had something like x plus 4 quantity squared, it would go through the minus 4, but it would actually bounce and not go through. All right. So this question asks you to put everything together. It wants you to find all the x and y intercepts, and it wants you to state the multiplicity. So I'm going to go ahead and pull out the x, and I get an x squared minus 2x plus 1. I'm going to go ahead and factor that. That's going to be, how do I add to minus 2 but multiply to 1? Well, that would be a minus 1 and a minus 1, because minus 1 plus a minus 1 is this. Minus 1 times a minus 1 is this. And of course, I can rewrite this as x times x minus 1 quantity squared. And our multiplicity is going to be 1 for this. So my solution of x equals 0 is my x-intercept, which you can write as 0, 0. But it also has a multiplicity of 1. Versus for this one, my solution is x equals 1, which is the coordinate 1, 0. And here I have a multiplicity of 2. So let's go ahead and look at this. You can see for our answer x equals 0, or the point 0, 0, where we have a multiplicity of 1, it just goes through the graph, crosses the x-axis. However, at x equals 1, or the coordinate 1, 0, where we have a multiplicity of 2, okay, this actually just plain old bounces off. It doesn't cross it exactly. All right, this problem is an optional one. If you feel like you get it, you can go ahead and close the video. But I'm just going to solve this real quickly. I'm going to have an x times an x squared minus 2. It looks like I can actually pull out an x squared, right? So I can actually write this as a x minus 2. Let me check that. That looks good. And so in this case, I actually have an x-intercept at x equals 0, or 0, 0. The multiplicity is 2. And you can see that's why it bounces off 0. Versus here, I have a 0 at x equals 2, meaning I've got an x-intercept at 2, 0, but my multiplicity is 1, meaning that it crosses. Now, I did forget to find my y-intercept, so let me just do that real quickly. That's me plugging in 0 for x, and I get 0, 0 as my y-intercept. And going back to the last problem, I think I forgot that as well. Here, plugging in 0, I would get the coordinate 0, 0 as my y-intercept, which, looking at the graph, you can see that that is true. Thanks for watching. I know it was a long one.